हेलो स्टूडेंट्स, मोस्ट वेलकम इन मैथ रीथ एकेडमी। तो हम लोग इंटीग्रल कैलकुलस पढ़ रहे हैं, जिसमें रीमान इंटीग्रेशन का चैप्टर हम लोग पढ़ रहे हैं। तो लास्ट क्लास में हमने कुछ फंडामेंटल्स, कुछ डेफिनेशंस को डिस्कस करा था। आज हम अपर एंड लोअर रीमान इंटीग्रल्स क्या होते हैं उनके बारे में बताएंगे, और कब फंक्शन हमारे पास रीमान इंटीग्रेबल होता है। ऑल थिंग्स आई विल डिस्कस इन दिस लेक्चर। ओके, तो फर्स्ट talk about the upper and lower Riemann integrals. Upper and lower Riemann integrals. Okay. जैसा कि हमने पढ़ा था कि फंक्शन शुड बी बाउंडेड फॉर द इन द इंटरवल ए कमा बी। ओके। एंड जो लेंथ होती थी सब इंटरवल्स की, उसको हमने डेल्टा आर से डिफाइन करा था। एंड द सुप्रीमम कैपिटल एम एंड इन्फिमम इज स्मॉल एम। तो अगर हम किसी इंटरवल के सुप्रीमम या इन्फिमम की बात कर रहे हैं, तो उसमें हम कैपिटल एम एम आर बोल देंगे, और स्मॉल एम आर फॉर द इन्फिमम। ओके। सो let fx be a bounded function. I'm just taking here. Let fx be a function bounded in the interval, closed interval a comma b, in the interval this is a comma b. Okay. And I'm just took this small m is the infimum, and capital M is the supremum. So let this small m and capital M, they are written here the lower and upper bounds, but small m and capital M are the actually infimum and supremum of the function uh, in the interval a comma b. Be the lower and upper bounds, because we know that lower and upper bound is so many, है ना, बहुत सारे हो सकते हैं। तो बट we are restrict our upper and lower bounds as supremum and infimum of fx in this interval a comma b। तो इसको यहाँ पर आप लिख लीजिए, दिस इज infimum and this is supremum. Okay. So let p the partition, which is the looks like this: x naught, this is the point a, x1, x2 up to here some xr minus 1, xr point is here, and this is x of n minus 1 and xn. So xn is the b point. So here n plus 1 points in this partition, and the interval will be made, n intervals will be formed. At n sub interval यहाँ पर बनेगी। Be any partition of this closed interval a comma b. Okay. So you know that if m is a lower bound, small m is the lower bound, and capital M is a upper bound, then the value of the function will lie between these 2 points. Okay, so here you clearly see this is fx is less or equal to capital M and less greater equal to small m, because small m is the infimum and capital M is the supremum. Okay, so if function is bounded, then it must be bounded in the subintervals as well, because भाई अगर बाउंडेड है इसका मतलब उसके उस थ्रू आउट इंटरवल उसकी कभी वैल्यू इनफाइनाइट नहीं हो रही है ना, वो बाउंड है। तो इसका मतलब है उसके हर एक पॉइंट पे उसकी वैल्यू फाइनाइट आ रही है। और अगर वैल्यू उसके हर एक पॉइंट पे फाइनाइट हो रही है तो कोई भी सब इंटरवल हम ले लेंगे तो उस सब इंटरवल के अंदर भी हमारी वैल्यू फाइनाइट रहेगी। इसका मतलब ये है कि फंक्शन अगर ए और बी में बाउंडेड है तो इट डेफिनेटली विल बी बाउंडेड in the subintervals as well. Okay, so you can also write this is also fx अगर बाउंडेड है तो उसका सुप्रीमम होगा, इन्फिमम होगा, लोअर बाउंड होगा, अपर बाउंड होगा इन ईच सब इंटरवल एज वेल। ओके, इच बाउंडेड in each subinterval in subinterval x r minus 1 x r for each r just equal to 1 2 up to n, means every interval it will be. So if I'm just taking small mr or capital mr as a infimum and supremum in each subintervals. Okay, so I'm just taking here, so let small mr sorry, capital mr and small mr are the supremum and infimum, be the upper, yeah, written here upper bounds of fx in this interval xr minus 1 xr. So and I'm just took, and this delta r is just equal to xr minus xr minus 1. It means length of the interval is represented by delta r. Okay, it upper bound and lower bound means this is supremum actually of the function and this is infimum. Okay, so you just clear about it. In your textbook, it is written in lower and upper bound, but we know that lower and upper bounds is more than one. So we just restrict ourselves as the supremum and infimum. Okay, so this is MR is the supremum in that interval of the function, and small MR is the infimum of the function in that interval XR minus 1 to XR. Okay, the sub interval के अंदर। सो अगर हम आर बराबर 1 ले लेते हैं तो फर्स्ट इंटरवल आ जाएगा दैट इज एक्स नॉट, मतलब A to x1। तो उसके अंदर जो हमारे पास सुप्रीमम है वो M1 है और जो इन्फीमम है वो स्मॉल M1 है। ओके, एंड डेल्टा आर वी जस्ट रिप्रेजेंट दिस इज द लेंथ ऑफ द सब इंटरवल। क्लियर? So we define two sums that is called Riemann sums. Okay, so we now form two sums and denoted by. So now define two sums. Fine. the sums capital S and small s by, तो कैसे हमने कैपिटल एस को डिफाइन करा है, दैट इज दिस. ओके, एंड दिस इज denoted by like this: u p comma f, where this is depending on this partition p of the function f. Okay, so what we are doing, we multiplying this capital M1, it means supremum of that interval with the length of the interval. Okay, supremum of the interval in that interval of the function with the length of that interval. Okay, in the second interval, for the second subinterval, this is M2, and this is your x2 minus x1. Okay, and similarly this is M3, means this is x3 minus x2, and so on. If we just multiplying the mn, it means the supremum of the function in the nth interval is just equal to xn minus xn minus 1. And here x naught is a, and this xn is b actually. Okay, so this summation you can also write in concise form. Summation, we are moving from r equals to 1 to n. Okay, and this is mr, and this summation you can write like this: this is xr minus 1. Okay, so it will be looks like this: this is summation r is equals to 1 to n, this is mr into डेल्टा. क्लियर? तो ये हमारे पास कैपिटल एस जो हमने सम को डिफाइन करा है, दैट इज योर. Similarly we defined the small s is just equal to, this is called lower sum with this, with respect to this partition p. So this is also mentioned p of this function f is just equal to small m. It means now the length of the interval multiplied with the infimum of that of the function in that interval. Okay, so this is x1 minus x naught, plus this is m2 is x2 minus x1, and this so on up to this is mn is xn minus 1. So this is actually summation r is equals to 1 to n. Okay, and this is m1 m2 up to mn, so this is mr, here will be mr, and this will be similarly xr minus 1. So you can just write here summation r is equals to 1 to n, this is small mr, and this is delta. Here delta are defined to be the length of the interval. You just remember it, because in the previous lecture, when we are writing the oscillatory sum and the oscillation, so in that the the difference between the supremum and infimum was defined by the delta. But here the delta is the length of the, so you just basically learn the delta defined to the length of the interval. Okay, you can use another symbol for that one. Okay, so you can just picturize this if you want. If you want to, let me explain some in the, so if you are having in this way, just wait. So this is, suppose that this is x-axis and this is y-axis, and we have somehow, this is the function, looks like this. This is a function. Okay, so you know that this is a interval. I'm just taking this interval of the function. We defined it. It is your point A, and this is somewhere point B. So if you are talking about the maximum value of the function, that is called the supremum, and the minimum value of the function is called the infimum. So here you can see this point. Here you can see this point is your minimum one. Okay, so सब गायब हो रहे हैं, क्या बात भाई? हमने ज्यादा बार कंट्रोल जेड दबा दिया। हम्म चलो कंट्रोल वाई करते हैं। एक, कंट्रोल वाई करो भाई। फिर से बनाना पड़ेगा क्या? हम्म चलो फिर से बना लेते हैं। So this is your x-axis, this is your y-axis. Suppose that we have some function here. Um, this looks like this, okay? So if I'm just having, this is point is your A, and I'm just checking, this is point is your A, and this is somewhere B, okay? So the minimum value, or you can say the infimum, is the, so I'm just taking, this is the minimum value of the, so that will be the infimum. So you can say this is your small m, this value is small m. And this is the maximum of this function in this interval a comma b. So this is, you can say this is your capital M, okay? If I'm taking some sub interval, suppose that I'm taking some sub interval here, I'm taking sub interval, this is your x r minus 1, and there is a somewhere x r, okay? So this thing, or the maximum is here actually. So this capital MR is this, and this is small mr in this interval, because this is decreasing. So this will be a small r, and this is capital R. So these values are actually the supremum or infimum of the function in this subinterval. Okay. So this is, we have somewhere x1, x2, and so on. Here somewhere this is xn minus 1. So this is some pictorial representation of the things what we are doing. So what we are doing, we just multiplying this supremum or infimum with the length of the interval. Okay, and then we take the sum of each interval. That sum, if we are multiplied with this supremum, that is called the upper Riemann sum, and if we multiply with the infimum, that is called lower Riemann sum. And this UPF is actually denoting the lower Riemann sum or the upper Riemann sum in with respect to the partition. And we know the partition is different. If you are change the point, the partition will be different. So sums will be different. There are for each partition the difference for each partition the sum will be different. Okay, so we will find the sum as that it possibly good enough. Okay, so you can just write here, and that's the name of this is your Riemann sum. So you can just write here the U P comma F. Okay, it's called the upper Riemann sum. It's called the upper Riemann sum. Sum of effects on this closed interval a comma b with respect to the partition p. Okay, so it means if we are changing the partition, the upper Riemann sum will be changed. Okay, similarly we can just say this is LPF. LPF is the lower Riemann sum. The lower Riemann sum. The lower Riemann sum. Okay, so you just remember these. इनको डार्वॉक्स सम भी बोलते हैं, तो you can also remember these. These are also known as upper and lower Darboux sums respectively. Okay, so just remember we are multiplying the supremum with the length of the subintervals and then added all these things, we will get the upper Riemann sums, and similarly for infimum we get the lower Riemann sums, and also known as the Darboux sums. Okay, if we varying the partition, so we will get the different set of values for upper Riemann sums and lower Riemann sums. The upper Riemann sums is often in this manner or are bounded below, and lower Riemann sum is bounded above. So one thing is very important, क्योंकि हमारे पास जो सम आएगा, बिकॉज फंक्शन इज बाउंडेड, तो वी गेट सम फाइनाइट वैल्यू, एंड एडेड सम फाइनाइट वैल्यू वी विल गेट सम अगेन फाइनाइट वैल्यू. ओके, इट मीन्स दैट जो भी हमारे पास सेट बनेगा अपर रिमान सम्स का, चेंजिंग द पार्टीशन, जब हम पार्टीशन चेंज करेंगे तो डिफरेंट डिफरेंट रिमान सम्स हमारे पास आएंगे, तो उनका जब हम कलेक्शन करेंगे तो वो जो सेट बनेगा वो सेट भी हमारे पास बाउंडेड होगा, बिकॉज उसके अंदर सारी की सारी फाइनाइट वैल्यू होंगी. तो वी हैव सम लिमिट कि भाई इससे बड़ी वैल्यू नहीं आ रही है, इससे छोटी वैल्यू भी नहीं आ रही है। ठीक है, तो हर अपर रीमान सम्स भी बाउंडेड होगा, और रीमान सब लोअर रीमान सम्स का कलेक्शन भी बाउंडेड होगा। ओके, तो अब अगर वो बाउंडेड हो गया तो उसमें से जो अपर रीमान सम जो सेट बना, उसका जो सुप्रीमम होगा, समझ पा रहे हैं? हमारे पास अलग अलग पार्टीशंस है, अलग अलग पार्टीशंस के ऊपर हमारे पास अपर रीमान सम्स आ रहे हैं, तो अपर रीमान सम्स का एक कलेक्शन हो गया। वो उसके अंदर फाइनाइट वैल्यूज हैं, फाइनाइट वैल्यूज हैं तो वो एक बाउंडेड सेट हो जाएगा। और बाउंडेड सेट हमारे पास है तो उसका कोई सुप्रीमम होगा, है ना, मैक्सिमम वैल्यू होगी, और उसकी एक मिनिमम वैल्यू होगी। तो दैट इज कॉल्ड इन्फीमम एंड सुप्रीमम। तो उस अपर रीमान सम्स के जो कलेक्शन का सेट है उसके अंदर हमारे पास सुप्रीमम भी है और इन्फीमम भी है। तो जो हमारे पास अपर रीमान सम है, उसका जो इन्फीमम होता है, जो सबसे मिनिमम वैल्यू होगी, दैट इज कॉल्ड द अपर रीमान इंटीग्रल। ओके, एंड इसी तरीके से लोअर रीमान सम्स का जो कलेक्शन है उसके अंदर भी सुप्रीमम होगा और इन्फीमम होगा। तो लोअर रीमान सम का जो भी सुप्रीमम होगा, जो मैक्सिमम वैल्यू आ रही होगी जिस पार्टीशन के साथ भी, दैट इज कॉल्ड द लोअर रीमान इंटीग्रल। ओके, सो ये वैल्यूज होंगी, क्योंकि ये हमारे पास लोअर रीमान इंटीग्रल मैक्सिमाइज करे, और अपर रीमान इंटीग्रल को हम मिनिमाइज करें, सो वी कैन गेट द integrals, we get the actual integral value in that interval. Okay, so that is called the, and if the both upper Riemann integral and lower Riemann integral are equal, then we can say the function is Riemann integrable. Okay, so let's write all these things what we have talked. Okay, so now by varying the mode of partitions of A comma B, now varying the mode partitions of A comma B, we get different sets, sets of values of upper sums, capital S, and lower sums, small s. Okay, so the upper sums obtained in this all, the upper sums capital S obtained in this manner are all bounded. Bounded below, and lower s are all bounded above, है ना? बाउंडेड above होगा तो सुप्रीमम होगा, और बाउंडेड बिलो है तो इन्फीमम होगा। ओके, तो नाउ डिफाइन द अपर रीमान इंटीग्रल। upper Riemann integral. So क्या होता है upper Riemann integral? Basically the infimum of the, because capital is bounded below. Okay, so there exists some infimum. So you can see the upper Riemann integrals of fx over the closed interval a comma b is the greatest lower bound or infimum of S. ठीक है. If you want to say, you can say in another words also. In other words, it is the greatest lower bound of the upper sum cube over all the partitions P on this closed interval a comma b, and is denoted by, so this is denoted by the some letter G, and this is actually infimum of this u p comma f. So this is denoted by the symbolism. This is a b bar, okay, fx dx. Okay, so this is the upper Riemann integral. So we took the partition, and हर एक partition पे हमने Riemann sum calculate करा. उन सब Riemann sum का जो सबसे छोटा Riemann sum होगा, that is called the Riemann integral. Okay. Similarly, we just talk about the lower Riemann integrals. Riemann integrals, lower Riemann integrals is what? So the lower Riemann integral of fx over this is closed interval, where the closed interval a comma b is the least upper bound. अब हमारे पास कितना इंपॉर्टेंट था, हमने सुप्रीमम और इन्फिमम को डिस्कस करा था. तो नाउ यू कैन अंडरस्टैंड वेल कि व्हाट इज द लीस्ट अपर बाउंड, व्हाट इज द सुप्रीमम. ओके, और भी सिंपली से दिस इज सुप्रीमम. Supremum of the smallest. So in other words, you can say it is the least upper bound of the lower sums over all partitions P on this closed interval a comma b, and is denoted by this is your I just equal to supremum of this is L P comma F is just equal to integration. This is A bar up to B. This is Fx dx. Okay, so this is the lower Riemann integrals. So this is notation to represent the lower Riemann integral with the symbol I, and this is J with the upper Riemann integral, and we just have this is A bar here. वे बार माइनस जो भी आप कहना चाहें, you can just say. So this is the notation of this Riemann. So when the function will be Riemann integrable, if this supremum and infimum will be equal. It means the lower Riemann integral should be equal to the upper Riemann integral. So then the function said to be integrable. Then value of the integration is one of the each. इनमें से किसी को भी हम उस इंटीग्रेशन की वैल्यू कर सकते हैं. तो when the function will be Riemann integrable, Riemann integrable. Okay, so if I'm saying the function is Riemann integrable, it means that the function fx is said to be Riemann integrable or integrable R Riemann integrable, or simply we can say integrable R if the lower Riemann sum Riemann integral is just equal to upper Riemann integral. If both are equal, then we say it is a Riemann integrable. Okay. So if we are saying if the upper Riemann integral are equal, we say that the function is Riemann integrable or integrable. Whatever you just say, simply this is some writing in this A comma B. And the common value is said to be the integral value. This is simply a to b, that is called integral value. Okay. So this is the, so it is not in each case the function is Riemann integrable. So it is only Riemann integrable if it is lower Riemann integral should be equal to the upper Riemann integral. Okay. So I hope so you understood the definition of the Riemann integration. Uh, it is some terminology that we used here that should be clear. Okay, so that's why I just written all the things by the textbook. Okay, so we will meet in the next lecture with some theorems. I just also write proof of the theorems, and we explain each and every term of the theorem, so we can able to solve the problems as well. And because in your examination there are MCQs, so if we know the definition well and we know the theorems or results well, we can easily answer the questions. Okay, so we will meet in the next lecture. Thank you so much for watching, for learning mathematics with me. Thank you so much.